Okay, pretty straightforward. Recall that the absolute value of x is equal to x itself if x is bigger or equal to 0, and the absolute value of x is equal to the negative of x if x is less than 0. And yes, I could have included 0 there or here. So this is what I'm saying. I could have done this and it wouldn't make a difference, right? Okay, but in any case, most importantly, the absolute value of x is defined piecewise like that. So we go, this integral is the same as -1 to 0. And for such x's, we see that the absolute value of x is equal to negative x. So e to the minus x dx, like that, right? And then we pick up where we left off, which is at 0. So we go plus 0 to 3. And for these x's, we see that the absolute value of x is just x itself, right? So like this, right? Okay, cool. Now, this first integral evaluated from -1 to 0 is going to look like this. First, the antiderivative of e to the negative x is negative e to the negative x. So we go evaluated from -1 to 0, right? And then we add to this the antiderivative of e to the x is e to the x itself. So e to the x evaluated from 0 to 3. Now, for this first piece, we plug in 0. We're going to get negative e to the negative 0, which is negative e to the 0. And we go minus, and then we plug in -1. So minus negative e to the negative 1. So just e to the first, right? And so we've evaluated that. And then we go plus. For this part, we go, we plug in 3. So e cubed minus e to the 0, which is 1, right? Okay, now some cleaning up work. So e to the 0 is 1, so this is -1. And then minus minus is plus. So we could just write a plus here, and e to the first we all know is e. So what do we have in total? We have e cubed, and then plus e, and then -2. Yeah? Okay, cool.